All right, so again, our chapter 5, it's only been 2 lessons. Okay? Today is 2 equations, 2 variables. Tomorrow's 3 equations, 3 variables. Or it'll be Monday. All right? So like I said, this is 5-1 for us, even though this says chapter 6 on the screen. And because basically this is just a straight review chapter of everything for 2 equations, 2 variables. All right? This is Algebra 1 days. Tomorrow, 3 equations, 3 variables. Sorry, next class, 3 equations, 3 variables. That's kind of back to your Algebra 2 days. All right? So we just want to go through these, just a little bit of review before we go forward, and because Penn Island says I have to do this with you, to get ready for the future. All right? So just a little bit of straight review. First one, solve systems by graphing. If you're going to solve systems by graphing, all you have to do is graph them on the same plane. Wherever they cross at is going to be your answer. That's going to be your x and y values. All right. So you won't have to write this down. It's definitions. Just for definitions, just remember, system of equations is a set of 2 or more equations that have the same solution. Solution of a system is an ordered pair that satisfies every equation. It doesn't just have to fit for one, it has to fit for all of them. Now, this one here is kind of a key one to remember. Whenever you graph 2 lines on the same plane, you have 3 possible outcomes. First outcome is they cross, so they intersect at one single point. If this is the case, the point that they intersect at is your answer to those 2 equations. All right, that's your x and y value that fits in both. So if lines intersect, they intersect at exactly one point, and that's your answer. If the lines lie on top of each other, then that's going to be infinite solutions because every single point intersects. And the last one is no solution. The only way you can have no solution is if the lines are parallel. Overall, this is probably 90% of line pairs. This is about 5%, and this is about 5%. Okay, that's just how it kind of comes out. Any 2 lines, they're pretty much going to intersect at one point and one point only. All right, parallel and equal are just kind of those rare instances. Obviously, perpendicular lines would fall into the one solution thing as well. All right, so that's the 3 possible outcomes. And again, you graph them on the same one, wherever they cross, that's your answer. So let's do one of these. So let's do the first one. Y equals 2x plus 4, y equals x plus 2. All right, we're going to graph the lines. Graph the first equation. Y equals 2x plus 4. So we start at plus 4, starting at y-intercept. Slope. Holy crap. That's not good. All right, my slope is 2x. So anytime your slope is a whole number, it's over 1. So it'll be 2 over 1. Up 2 over 1. And I can just continue on that in both directions to make my line more accurate and then connect the dots. Sometimes you got to go a little farther, sometimes not. Second one, y equals x plus 2. So I'm at plus 2. My slope is 1, up 1, over 1. And I can do that in both directions to make it more accurate. Sometimes you have to go farther. So those 2 guys intersect. They intersect right there. They intersect at the point -2, 0. So that would be my answer. You guys remember doing those every single year? I'm trying to hit them quick. All right. So that is solved by graphing. Obviously, if you have bigger numbers, Desmos would be your best bet. You go on Desmos, type in the 2 equations. If you click on the lines, it will highlight the point that they cross on. Okay. I'm not going to spend much more time on that. We'll get to different word problems here in a little bit. All right. Second kind is solving systems by substitution. You guys probably had me for this, didn't you? Way back. All right, so solving systems by substitution. Here's your steps for substitution. Solve one of the equations, get one of the variables by itself. Substitute that value is equal to into the other equation. Solve for the remaining variable and plug that answer back into the first equation. If you remember, I teach this a little bit different. This is the one where you, all right, this is where you box it, and then this is back into the box. You remember doing that with me? Yeah. All right, so let's look at one of these. Let's look at this guy. First thing I want to do, I want to get a variable all by itself. I'm looking at that one. I have x minus y up top, and I have a y on the bottom. I want to try to stick with one of those guys as much as possible, get that all by itself. I like the x in the first equation because it's positive, and it's pretty much by itself. Okay, so I'm going to break this one down. X minus y equals 2. Solve for x. So I'm going to add the y over, get x equals 2 plus y. Box that guy up. Okay, put that into the other equation for x. So 2 times 2 plus y equals 1. Distribute. So I get 4 plus 2y plus y equals 1. Combine like terms. I have 3y equals, I'm going to subtract the 4 over, negative 3. So y is going to be negative 1. Put it back in the box. X equals 2 plus a negative 1. So x equals 1. You're all experts on that one, right? All right, so that was substitution. We probably did hundreds of those. Let's flip to elimination. Elimination is slightly different. If you guys remember back, which one do you like better, elimination or substitution? All right, here's substitution. Here's elimination. Okay. I mean, it varies, but usually most years I'm going to say it's probably 60-40 elimination. Me personally, I like substitution because it's the same every single time. You know, elimination, sometimes you get really short ones, sometimes they're really long, whereas substitution is basically the same every single time. All right, so elimination, you want to make one variable the same in both equations, one positive, one negative. Add the two equations together, solve for the remaining variable, then plug it back in the first equation. And we have different levels of difficulty for these. This one here, the y's cancel out immediately. This one here is a little tougher. Let's look at this guy. All right, so I want to make one of my set of variables the same, one positive, one negative. So I'm looking at that. I got a 9 and a 3. I got a 5 and a 1. Both of them are factors of each other, aren't they? Let's want to go x's. All right with that? Let's cancel the x's. So what would I want to multiply the second equation by? I want to multiply it by 3. I'd make it negative 9. Let's just make it a positive. Let's multiply by negative 3 to change the sign. That work? That will make it opposite. So I'm going to multiply the second equation by negative 3. It's going to be positive 9x minus 3y equals negative 12. I'm going to copy down the first equation just to make it a little prettier. All right, this is going to go away. So I have 2y equals negative 13. This guy's going to be a little ugly. Divide both sides by 2. Y is going to be negative 6.5. Okay, that's the first one. Take it, plug it back into one of the originals. So let's plug it into number 2. 3x plus a negative 6.5 is 4. Add the 6.5 over, so I have negative 3x is equal to positive 10.5. Divide both sides by negative 3. X is going to be negative 3.5. All right, good with that? Remember doing those? All right, so the big thing I want to do, let's look at, oh, here's the one. If the variables cancel out and it's a false statement, so if you end up with something like 3 equals 4, that'd be no solution. If your x's or y's cancel out and you're left with something like 7 equals 7, then it would be infinite solutions. Good with those? All right, so let's look at some word problems. This is kind of the big part I want to get back to. So there's a couple of different types of word problems. Unknown numbers, break even, coin problems, wind and current problems, and mixture problems. So let's look at one of each of those. These are the most common type. What do you look scared for? Aren't you glad we're doing that? Did your hand up? All right, let's look at the first one. So obviously I have it written out, but Sometimes you get ones like this. You need to break down the wording that's in the problem. Okay, first number is 4 less than a second number. 4 times the first number is 6 more than twice the second number. Find the numbers. All right, just break stuff down. Look at what you're doing. All right, first number, we call it x. 4 less than, that means minus 4. Second number, we just called that one y. 4 times would be multiplied by 4. First number 6 more than twice a second. Twice would be times 2. Just remember those key things. I think those ones are pretty simple overall. Do you guys agree? All right. Now let's get these. This is one of the most common types of break-even problems. This is a pretty low level one, but there's two things you want to look at. In a break-even problem, how do you identify this? Well, you just pretty much always going to say in the last sentence, when do you break even? Or when do your profits and costs match each other? Those types of things. All right? So anytime you have a break-even point, you need to have a cost equation and a profit equation. Okay? So looking at this guy, fashion designer makes and sells hats. The material for the hat costs $5.50. The hats sell for $12.50 each. Designer spends $1,400 on advertising. How many hats must the designer sell to break even? So first off, let's talk about our cost. Which numbers up there are cost for us? Correct. So what's the 550? That's what? I'm just talking. What is the 550 like in the problem? Okay, yeah, be the material. It would be what you're paying the company to produce it before you sell it, right? That's what you're paying the factory or wherever it's coming from, or the factory in China that everything seems to be made in. All right, and then after that, you also have advertising. That's next extra $1,400. Now, looking at this problem, is that advertising ever more than once, or is that a one-shot deal? I mean, based on the problem, what do you think? It's a one-shot deal. Yeah. So we're not only going to buy one hat, right? Every single hat costs us $5.50. So that'd be $5.50 times the number of hats that we have to produce. Now, looking at this, the designer spends $1,400 on advertising. Does that say each month, each year? It just says he spent $1,400. All right with that? All right, so anytime you have this, let's go cost. We'll say cost is, we'll start with y equals. I like to always set these guys as y equals. Y is just kind of our money. Y would be our money thing for this. So if you want to identify our variables, y is going to be the money. We'll say x is the number of hats. Good with that? So the first equation, my cost is y equals what costs $5.50 for every single hat. So we have to multiply that by the number of hats we have. And then we got that extra $1,400 that we dished out that we have to worry about too, right? Now my profit, how much do I make per hat? Okay, that would be how much I would make per hat, right? But let's account for the whole thing, okay? Because even though I paid out the money first with, if you buy a hat from me, you still gave me $12 or $12.50. Make sense? So my profit then would be 1250x. Okay. That we were, if you subtract the 550, then you're kind of looking at profit margins. That's a whole different ball game. All right, so there's my two equations. What are you gonna do? Substitution, elimination. I think substitution looks pretty darn good. So I can just put this right there, right? So I have 1250x equals 550x plus 1400. So I'm gonna have 1250 minus 550. What's that gonna be? 7. 7x equals 1400. So x is gonna be what? 200. All right, I want to plug this back in just to find my y variable as well. So we'll put in the second one, y equals 1250 times 200. What's 1250 times 200? Anybody got that one for me? We got 2,500. $2,500. All right. So that means my answer, x is 200, y is 2,500. What's that mean for us in the grand scheme of things? What's that mean? 200, sell 200 hats to break even. And at what amount did that cost me? In both directions. Correct. 2,500 bucks. So it cost me. I have to spend 2,500 bucks before I can start making any money. All right. After that, if I sell 250 hats, I'm in good shape. If I sell 180 hats, I'm still in the hole. Right? So that's what a break-even problem is. Issues on that? All right, next one, coin problems. I think coin problems are fun. They're probably like my favorite type. They're not stupid. All right, so coin problem. You have a jar full of pennies and quarters with a total of 27 coins. Total value of the coins is $4.35. How many of each type of coin do you have? All right, so a coin problem. Again, the ones I'm using here are pretty simple, but the same form will work for each one of these styles. You know what I'm saying? So a coin problem, anytime you have a coin problem, you need an equation for the number of coins, and you need an equation for the value of the coins. All right, that's how you want to break these guys up. So for the sake of this, when we're looking at pennies and quarters, let's say pennies are X, quarters are Y. You guys go with that? All right, so the number of coins, that's always the easiest one to do. How many coins do I have total? I got 27. Okay, 27 coins. So number of pennies plus the number of quarters is going to be equal to 27. That's the easiest equation there is. It's going to be X plus Y equals whatever. Unless, I mean, they might sometimes throw in and say you have like twice as many pennies as quarters. Okay. All right, then the value, this is the only one that's a little bit tricky. This one you have to account for the value of each one of the coins. Okay? How much is a penny worth? 1 cent. So it'd have to go 0.01x plus, how much is a quarter worth? 25 cents. So we have to go 0.25y, and that's going to be equal to 435. Okay? Now I really don't want to deal with this in decimals, do you? So let's multiply everything in that equation by 100. Multiply by 100, so now I have 1x plus 25y equals 435. Did I change the value of that equation? No. I did the same thing to everyone. Did I change what my final answer is going to be? No. For some reason, I don't know why, but anytime we do that rule, especially like algebra, when you're first learning this, if you multiply everything by 100 in a system, they think, oh, okay, I multiplied by 100 now, so my final answer I have to divide by 100 to undo that. Nah. Oh, believe me, I've seen some crazy stuff. All right, so let's go substitution. You guys good with that? Let's run through it substitution-wise. I'm going to take the first equation. I'm going to subtract the y over. So I have 27 minus y. That's going to be my box item. All right, so I'll put that in for x. So I have 27 minus y plus 25y equals 435. Okay, combine like terms. I'm going to have 24y, and I'm going to subtract the 27 over. So I'm looking at 408. Yeah. Okay, divide both sides by 24. Y is going to be 17. Is that right? So y is 17. Plug it back in over here. So x equals 27 minus 17. X is going to be 10. Question on this. Still feeling good about life? Why do you have a scared look on your face? Huh? It looked painful. All right, next one. Good with that one? Good with the coin problems? Okay, wind and current problems. All right, these will be the ones where you have airspeed, you have river speed, those types of things. Okay, these ones are a little trickier. Now, anytime, I'll just wait till you hit when you have my class next year. We get to pre-calc. Yeah, when? How many of you guys are taking pre-calc next year? That's your only choice to go on from here. Might as well take pre. It's so much fun. See next.
So much fun as you explain how painful it is.
You see, if I pass this class, I will run out here.
Let's take
All right. So we're going to do wind current problem, and we're going to do a mixture problem. So wind current problem. Passenger travels from Charlotte to Los Angeles. At the same time, another passenger travels the same route in reverse. Airspeed of each plane is the same. The ground speed of the west flying plane is 495 miles per hour. The eastern traveling plane has a ground speed of 550 miles per hour. The wind is blowing west to east. What's the wind speed? What is the airspeed of each plane? What's the difference between airspeed and ground speed? What's that? There's less resistance, okay? So basically, for lack of a better term, the ground speed is your resultant speed, okay? So, if I'm in a plane and I set the cruise control at 200 miles an hour, does that mean I am going 200 mile an hour relative to the ground? No, okay? If I set my car at 200 mile an hour, okay, that's really fast. If I set my car at 200 mile an hour, I don't have any other effects on it, right? I'm actually counting that I'm crossing the ground at 200 miles per hour. But if I set my plane at 200 miles per hour, that wind might be helping me along. Now the speedometer in my plane doesn't really account for that, does it? No, the plane is still flying. Whatever the RPMs the engine has to be running at to achieve 200 miles per hour, that's what it's measuring. All right, there's no type of way to measure that in the air. Right? On the ground, your tires are measuring it because your tires are traveling the same distance every time. In the air, you set it 200 miles an hour, you might be going a little faster because the wind's helping you or the wind's fighting you. Does that make sense?
You ever wonder why planes are so fast? Like what?
No, I never really think of it. All right, so anytime you have this, you got your airspeed plus your wind speed equals your ground speed, okay? Now, obviously, plus the wind speed, if it's fighting you, you're going to be a minus or so on. Okay, but that's how you want to set these up. So anytime you're going to have these types of problems, you essentially have two equations. One's going to be to, one's going to be from. This one, we're looking at two different planes. Okay, a lot of times it's like to and from. AS, airspeed plus wind speed equals ground speed. All right, so the first one, passenger travels from Charlotte to Los Angeles at the same time, another passenger, blah, blah, blah. All right, so the ground speed of the west flying plane is 495 miles per hour. So the first one, it's going west. And the ground speed of it is 495 miles per hour. The eastern traveling plane has a ground speed of 550 miles per hour. The wind is blowing west to east. What's the wind speed? What's the airspeed of each plane? Okay? You guys good with this so far? Okay, so I got my ground speed, that's my resultant speed. Now looking at this, it tells you that the wind is blowing west to east. But at the same time, you should be able to look at this and say, all right, this guy's slower, so obviously the wind's fighting this one, helping this one. Agreed? So what we want to do, we don't know the airspeed, we don't know the wind speed, but it's the same. So we're just going to use x and y for both of those. So x is the airspeed, we're going to say that y is the wind speed. All right with that? All right. This one here, the first one, the wind is fighting us, so we have to subtract the wind speed. This one here, the wind is helping us, so we have to add the wind speed. Still good? All right, so now we have everything we need now to find the airspeed and the wind speed of both of these. Let's just go substitute or elimination. That work? We can just go straight down from here. So 2x equals, oh, what's that going to be? 1,045? All right, divide by 2. So we're looking at 522.5. So my airspeed essentially what the airplane is set, what it's set on cruise control at is 522.5 miles per hour. Now we just got to plug that guy back in to figure out the other one. So let's plug it into the second one. X is 522.5 plus Y is 550. So I'm going to subtract that across. Y is going to be 22.5. So therefore, my wind speed is going to be 22.5 miles per hour. Does that make sense? Okay. All right, let's go through the last one. Even if we don't get the last one solved, we can at least set it up. Okay. Now, if you're in a boat, the other ones, a lot of times you're in a boat, it's going to say like speed of the boat is blah, blah, blah. And it's going to say the speed of the boat relative to the bank. The bank speed would be your ground speed. The boat speed would be your airspeed. Make sense? All right. Last one. Chemist is working on a flu vaccine. It needs to mix a 10% sodium iodine solution with a 60% sodium iodine solution to obtain 50 milliliters of a 30% sodium iodine solution. How many milliliters of each solution should be mixed? I'm not good at chemistry. All right. Sure. Let's put some salt in your body. All right. So a mixture problem is basically a coin problem. Okay. Two things. We're looking at amount and we're looking at what's the word? What's it? Not consistency. What is it like when something is a 30% solution? What's the 30% is called? How? Not diluted, but let's say percentage for the lack of for the problem. So here's how we set this up. Amount, we're looking for how many milliliters total? 50, right? Okay, we want 50 milliliters. That's how much we want total. So that's just going to be X plus Y equals 50. Okay, we have two solutions. We have 30%, the 10% and the 60%. All right, so then now for percentage, I want to take the first one, the 10%, so it'll be 0.10x, plus however much of the 60%, which would be that. Here is the only tricky part, okay? What do we want our percentage to be in the end? We want it to be a 30%, okay? Now we have to attribute that to how much we are doing with it, okay? So I need to take my 30%, which is what I want. How many milliliters do I want total? 50. What is 30% of 50? 3 times 30. No. 30% of 50 would be 15. That'd be 15. So that would be equal to 15. Okay? This one here is the only tricky thing. You have to take your percentage times your amount and put it in. All right, then you can just solve it, substitution, elimination, any way you want to. Got it? Okay, you'll be a homework assignment up. Make sure you get it done. Have a good weekend. I'll see ya.